So let's create a function to solve the maze. Let's call it solve maze. And this function is going to take maze, which is a matrix, x position of the ret, y position, a solution matrix, and n. N is the length of each row or the length of each column. Now the first thing that we gotta do is to check if the current cell is inclusive or not. So if is safe, and this method is going to take the maze, x coordinate, y coordinate, and n. So if it is safe to include this cell, then we're gonna add 1 for that cell in the solution matrix. Now let's create this function is safe. Def is safe, and these are the parameters. So when it is inclusive or safe to take that cell, this is when x and y are inside the maze. That is, x is greater than equal to 0, and also y is greater than equal to 0. Y 0 greater than equal y, and when the cell is having value 1, maze xy is having value 1, then we will return true, else we will return false. Now after selecting the cell in the path, we're going to move forward from here. First in x direction. We have taken x as row in this example. So when we change x, then we are changing the rows, right? So we actually are moving downwards when we change x. So x is downward direction. So let's go downwards. Now let's call solve maze recursively to go downwards, and here we will pass the maze. We are changing x, so we will increment it by 1 and we'll keep y same. Now let's pass the solution matrix and n. If there is a path there, then we will return true, and then we go in y direction. So here y direction is actually forward direction. So here we will keep x same and we will increment the y. We'll pass solution matrix and n. So this is the y direction. Y is columns. So when we are changing columns, this means we move horizontally, right? So if we find a complete path from here, we will return true from here. Return true. Else, this cell cannot lead us to a solution path. So we need to backtrack and undo our decision for the current cell. So we will set this cell, maze xy, back to 0. And we will return false from here. False. And also when the cell is not inclusive, then also we are going to return false, right? So here return false. Now the base case when we reach to our goal, which is when we reach to the last cell. So when x is n-1 and y is also n-1, which is the last cell, and the value at that cell is 1, then 1, then we will update 1 in the solution matrix for this cell, solution x y 1, and this means that we have found the path if we reach to the cell, so we will return true from here. So this is the solution implementation to this problem. Now let's create a maze or a matrix. Maze, this will be a 4 cross 4 matrix. So let's pass the values. 0, 0, comma, the second row, 1, comma, 1, 1, comma, 0, comma, 1. Now the third row, and the last row with 0, 1, 1, and 1. Now we need a solution matrix, so we are going to initialize a solution matrix. Solution will be having 4 rows, so for I in range 4, and in each row we will be having this value, and each row we will be having 4 values, so for 0 for j in range 4. And we need to pass a number of rows, or you can say number of columns, both are equal. So let's find the length of the maze, and this is n. Now we are going to call solve maze function with all these parameters, and if it returns true, then we will print the solution. So if solve maze with parameters maze, the initial position of red will be 0, 0. Now let's pass the solution matrix and n. If this returns true, then let's print the solution matrix. For I in solution and for j in I, print the values. Print strj end it with print empty space. So this is the implementation. Now let's run this implementation and see this path that we get. We first are going downwards, so it selects this path. So this is how we can solve this maze problem.